Welcome to Mathematics Lecture Series, Laplace Transform multiplied by t power n property. Discuss, and this is lecture number 7. Today it is a multiplication by Tn property. A statement: if Laplace of f of t f of s, then Laplace of t power n multiplication with the function f of t, which is equal to minus 1 power n f of ns, where f of ns represent the nth derivative of the f of s. So we have to prove this Laplace of t power n f of t minus 1 over n f of ns. You know that the definition of the Laplace of f of t always represent by f of s, which is integral 0 to infinity e power minus st f of t dt. Differentiate both sides with respect to s and using Leibniz theorem of integration under differentiation, that is, taking differentiation both sides d by dx f of x dy, it becomes partial derivative if we take to the outside the integral dou x f of x dy. So taking here integration derivative both sides, differentiate with respect to s. So d by ds f of s, here d by ds 0 to infinity e power minus st f of t dt. Now this derivative take to inside the integral, it becomes partial s e power minus st f of t dt. Here t treated as a constant and taking derivative with respect to s of this function, so it becomes e power minus st minus st derivative minus t, we have right here, it becomes minus t e power minus st f of t dt. Then this minus you can write here minus 1 over dou d over ds f of s e power minus st t f of t dt. So by definition of Laplace transform, we can call this Laplace of t f of t. So minus 1 power 1 d over ds f of s is equal to Laplace of t f of t. Similarly, taking again the derivative with respect to s using Leibniz theorem, we obtain, so minus 1 of d square ds square f of 0 to e power minus st t square f of t dt, Laplace of t square f of t. Similarly done this whole process, taking again derivative Leibniz theorem, so you will have minus 1 square d squared d over ds square f of s is equal to Laplace of t square f of generalized. So we will have minus 1 over n t power n ds and f of s is equal to e integral of 0 to infinity e power minus st t power n f of t dt. So which is equal to Laplace of t power n f of t. So we can say that Laplace of t power n f of t dt is equal to minus 1 power n dn over ds and f of s, which is equal to minus 1 power n f of ns. Example number 1. Find Laplace of t square e power 2t. Know that Laplace of e power 2t is equal to 1 over s minus 2. This is f of s. So by using multiplication by Tn property, Laplace of t square e power at, which becomes minus 1 square t square over ds square 1 over s minus 2. So Laplace of t square e power at is equal to minus 1 square d by ds 1 over s minus 2. Taking derivative minus 1, so minus 1 becomes coefficient and minus 1 into minus 2. So derivative, first derivative minus 1 over s minus 2 square. Similarly, taking another derivative, so minus 1 minus s minus 2. So it becomes minus into 1 plus 2s minus, which is 2 over s minus 2 power 3. So Laplace of t square e power a t is equal to 2 over s minus 2 power 3. Find Laplace of t e power minus 4t sin 3t. Laplace of t e power minus 4t sin 3t. Before you find the Laplace of t sin 3, then use the first shifting property. Laplace of t sin 3t. Here we use the property t power n. So here t is 1, so minus 1 power first time the Laplace of sin 3t minus d by ds sin 3t Laplace is equal to 3 over s square plus 9 by the formula sin a upon s square plus a square. So by taking derivative so it becomes taking derivative, so here minus 1 s square plus 9 and the derivative of base 2s, so it becomes 6s over s square plus 9 whole square. Now use first shifting property on the one, so Laplace of e power minus 40 t sin 3t. So here you must replace s with this scale s plus 4. Here you have to s replace with s plus 4, 6s plus 4 over 6 plus 4 square plus 9 whole square. 6s plus 4, s plus 4 square, so s square plus 8s plus 16 plus 9, 25 whole square. So this is a last answer of the Laplace of t power minus 40 sin 3t. So we have the end of this lecture. Subscribe the channel and share the video. If you have any confusion, so you can write in comments. Thank you.